Welcome to this explainer. If you are gearing up for the ATI TES version 7, you already know it's a massive stepping stone for your nursing or allied health journey. But let's be honest, studying endless textbooks isn't always the most efficient way to prepare. So today, we're actively breaking down real sample questions across multiple disciplines. We're not just going to look at the right answers, we're going to literally reverse engineer exactly how the test makers want you to think. Here's our game plan for today. First, tackling the TEAS exam itself. Then we'll hit science with the genetic messenger, math by calculating staff probabilities, reading to find main ideas, and finally, avoiding those sneaky test-taking traps. Let's just dive right in.
Section 1, Science, specifically the genetic messenger.
Okay, so unlike some other sections of the test that give you giant paragraphs of context to lean on, success in the science portion, it mostly hinges on quick-hit factual recall. Take a look at this classic cellular biology question. It's asking us to identify a specific molecular messenger from a list of 4 options: lipids, DNA, RNA, or proteins. At first glance, if your cellular structures are a little fuzzy, all 4 of these might look like perfectly viable sciencey terms, right? But let's look closer at the wording. Pause and really hone in on the stem of the question here. We need to pinpoint the exact molecule responsible for carrying genetic information out of the nucleus and delivering it to the ribosomes. The absolute keywords here are messenger, nucleus, and ribosomes. Now, DNA holds the master blueprint for sure, but it's locked inside the nucleus. It's stuck there. It desperately needs a courier. So the crucial point is understanding that courier's identity. The correct answer is RNA. Specifically, messenger RNA, or msRNA, perfectly matches the biological definition of the genetic messenger. It acts as the physical bridge between that hyperprotected DNA inside the nucleus and the protein-building ribosomes out in the cytoplasm. Memorizing these specific roles, knowing exactly who the blueprint is, who the courier is, and who the builder is exactly how you conquer the science section.
Moving right along to Section 2, Math, where we'll be calculating staff probabilities.
Now we're completely shifting gears from vocab to rigorous data interpretation. We've got a scenario here with a county hospital staff distribution table. It breaks down male and female employees by their specific roles: practical nurses, or PNs, and registered nurses, or RNs. Now I know on a ticking clock, a giant table full of numbers can trigger instant test anxiety. Your eyes just kind of dart everywhere trying to process the whole shebang at once.
But here is the absolutely crucial step. You have to let the question boss you around. Let it dictate exactly where you look. Isolate the specific condition being asked. Which of the following is the probability that an RN is a male? Notice what it is not asking. We are not looking at the whole hospital staff. We are specifically and only looking at the probability that a registered nurse, an RN, is a guy.
To save yourself from visual distraction and totally preventable math errors, you've got to block out the noise. Actually, mentally, or even literally with your hand if you're practicing. Cover up the PN column entirely. Just hide it. It does not matter that there are 30 male PNs or 50 female PNs. Scratch that from your brain. We are focusing exclusively on the RN column, which clearly shows 50 males and 70 females.
And this brilliantly illustrates how totally manageable math becomes when you chop it into bite-sized steps. Step 1, find your new total universe of people, which is just those RNs. 50 plus 70 gives us 120 total RNs. Step 2, find our target group, the male RNs. That's 50. Step 3, just set up the probability fraction. We place the 50 male RNs right over the 120 total RNs, drop the zeros to simplify, and boom, we easily arrive at the correct answer of 5/12. By filtering out the junk data first, that actual math literally takes less than 10 seconds. All right, on to Section 3, Reading, and the art of finding main ideas.
We are now stepping into what is arguably the trickiest terrain to examine a classic, high-stakes trap that catches thousands of smart students every single year. Comparing these two passages side by side, one about community clinic attendance and the other on meteorology and clouds, this brilliantly highlights how the exact same fundamental skill is tested across totally different subjects. I mean, they look completely unrelated, right? But while the subject matter completely changes, the test maker's strategy for trying to trick you stays exactly the same.
Let's zoom in on that clinic passage first. The text outlines a very specific problem. Missed appointments spiked during the rainy season because of transportation and work schedule barriers. It then dives into the subsequent solutions the clinic tried out, like firing off reminder texts, staying open later, and even partnering with a van service.
The final results? An 18% drop in missed appointments.
So when we're asked for the main idea here, the correct answer choice is a problem was identified and practical steps were taken to improve it. And this works perfectly. Why? Because it's broad enough to comprehensively cover the entire narrative arc of the passage. It wraps up the beginning, the middle, and the end without getting tangled up in the hyper-specific details of that van service or the exact 18% statistic. It acts as the perfect giant umbrella for the whole text.
But okay, let's look at this second passage about the clouds. Here, some test takers selected the answer, the description of cumulus clouds. And you guys, this right here is our trapdoor reveal. It is a perfectly disguised, totally incorrect distractor. It sounds incredibly plausible because, well, cumulus clouds absolutely are described in the text, and they take up a huge chunk of the sentences.
Looking at this comparison, though, we can build a universal testing strategy. See, the meteorology passage explicitly details the formation of both cumulus and stratus clouds. So selecting an option that only mentions cumulus clouds, that's falling for an answer that is way, way too narrow. It completely ignores the entire second half of the paragraph. A true main idea absolutely has to cover the whole text, just like that clinic answer did. Distractor answers love to state a completely true fact from the passage, but they fail to act as an umbrella for the whole thing.
Which brings us perfectly to section 4. Avoiding test-taking traps.
So, what's the big takeaway after jumping across biology, math, and reading? Let's bring all these individual breakdowns together into one final overarching strategy for your exam. Success on the TEAS demands so much more than just baseline knowledge. It requires precise vocabulary recall, knowing exactly what an mRNA messenger does. It requires the absolute discipline to visually filter out all that statistical noise in a table so you don't calculate the wrong probability. And honestly, most importantly, it requires a sharp eye for answers that only give you half the story. Distractors are specifically designed to look friendly and familiar. Your job? Interrogate them. As you continue prepping for the big day, ask yourself, are you just casually searching for the right answer, or are you actively hunting down the traps? The next time a multiple choice option looks just a little too friendly, you've got to ask yourself, what exactly is it hiding? Thanks for joining me on this explainer, and I'll see you next time.